Let's get. How you doing, everybody? Thank you for coming to another episode. We have the Viking Samurai as usual, and we have Heiner, a very brilliant man that I know through a venture that we're doing, working with the Ukrainians on a very unique project. He comes to us from Canada, and he has a vast background in engineering and has dabbled in many different areas of engineering. Heiner, go ahead and tell us a little bit about yourself.
I'm a mechanical engineer, graduated in 1994, University of Windsor. Before that, I was a mechanic. So I come from the practical background. And I do a lot of cool projects in automotive and airplane engineering. Never the airplane itself, but everything around the airplane. So everything from the wagon that destroys your luggage on the airport to, the stairs that you stumble down getting off the plane, things like that.
Speaking of the wagon that destroys luggage at the airport, man, it's nuts. You would not believe what, I don't know if I should name the airline, but what the airline did to Rene Perez. He's a filmmaker, what they did to his camera equipment and lenses. They literally broke them all. And of course, I've been fighting back and forth. We were shooting a movie called Bloodstorm, by the way, and we went from California to Oklahoma to shoot the opening scene. But anyway, he gets back to Redding, California, and this camera case is like open. The lenses are cracked. It's like somebody rummaged through it. It was insane, man. And they're refusing to pay because they're refusing to reimburse. They say, oh, well, we don't reimburse electronics and all this and that. I'm like, but you guys literally trifled and rummaged through it, and it looked like somebody broke it on purpose. Anyway, I've been fighting with them over it, and we're not too happy. But check out the Instagram page, Bloodstorm Movie. It's a cool movie. But hey, Brian, so how did you and Heiner actually meet? Because there's kind of an interesting story here with this venture.
Yeah, we're working on an R&D project with individuals in Ukraine with some technologies. I don't want to go into too much detail about it, but I met Heiner, was recruited into the program itself, working on some very high-tech stuff to assist the Ukrainians in this conflict. We have a really incredible group of scientists, engineers, just absolutely brilliant minds. Heiner's really one of the leaders of what we're doing. I mean, without him, I would be completely incapable because, my idea of science and engineering are pretty bad. So without him there to kind of decipher everything and keep these organizations focused on the project and the end goal of what we're doing, I couldn't do it without him.
Thank you.
Okay, Brian, you follow the Ukraine conflict pretty heavily, and I know you're good buddies with Artur, one of the top influencers on YouTube who does Ukraine content. Do you have an opinion on when you think that may finally end? Because I know the news is really just focusing on Gaza and that kind of stuff, but obviously, unfortunately, the stuff with Ukraine and Russia is still going on as we speak. You have any projection on when that might finally end?
I think it's really about a war of attrition. So it's just a matter of how it's production. And I can imagine Heiner can speak on this. It's just about sustaining the war, sustainability. How fast can you manufacture? How fast can you get stuff to the front lines? And it's just a war of attrition. Really. Mm-hmm. So when it ends, it's just a matter of when they no longer can bring the ability to project power in Ukraine. That's just it. Once they hit that threshold and what they're losing cannot meet what they're making or what they're doing a lot of rebuilding of old weapons platforms like tanks and artillery pieces and all kinds of stuff. And it's just how fast they can refurbish and replace. And there's going to be a threshold where that just can't be done anymore, in my opinion. And that's probably within, if I'm being hopeful, maybe 8-9 months. But I don't, Heiner, you know more about the manufacturing aspects.
Well, I have a slightly more pessimistic view on some things. Is that every war Russia has been in, they started by being slaughtered, and just decimated and performing really poorly. And then after a year or two, they start getting serious and they start manufacturing and they start getting their ducks in a row and they start getting on a war footing and really getting their act together on the whole thing. Even if they're technologically behind us, they're an adversary that is willing to lose any number of people. Like whether they lose 500,000, 1 million, 2 million people, for them, that, you know, as I think Stalin said, that, you know, when someone dies, it's a tragedy. When 100,000 people die, it's just a statistic. And that is truly their philosophy. And at the moment, they're outproducing the West in low tech things like artillery shells, be that being made internally or acquiring them from North Korea and other proxy nations around, you know, supporters. So if the West doesn't take this seriously and start manufacturing and really ramp up support of Ukraine, this may go on for much longer than we hope. And we may lose this if we do not take this seriously. And us sitting back and squabbling about levels of funding and tying it to other unrelated items in Congress and the EU being blocked by Viktor Orban is basically, you know, sending a message to Putin that we're not serious and we're willing to have him outlast us because we don't have the drive to win.
Yeah. Well, let's talk about the gravity discussion. So, how would you define gravity, first of all, from like a scientific explanation? Because with me, as more of a layman, I just think, well, that's kind of literally keeping me grounded. Like if I jumped, I'm back here, gravity's putting me back in place. Like how do you define it from like a scientific perspective? Because you can't see it.
No, gravity's the weakest of the four primary forces, and we don't understand why it is so weak. It's much, much weaker than, you know, electromagnetism. You know, it's much weaker than the weak force, which holds, you know, atoms together, and the strong force, which holds quarks and other molecular particles together. So it's and another thing, the formulas for gravity have some very interesting characteristics. Nothing can travel faster than the speed of light, for instance. That's one of the rules of the universe. However, if a planet were to double its mass instantaneously here, the effect of that would be felt instantaneously at the other side of the universe. So the effects of gravity are instantaneous and travel faster than the speed of light. And things like that are very, very, you know, interesting how that is possible. And it is so weak, and they don't understand why it's so weak. And some theoretical cosmologists have theorized the reason it is so weak is that we are just in one universe, and there are many or countless other universes in the same space at the same time, and gravity is bleeding through from different dimensions of universes, and we are actually in the middle of a whole bunch of mass floating, and that's why we're being pulled in all directions, and gravity is so weak. That's one of the, you know, more recent theories as to why the force of gravity is so weak, which is kind of cool. Like if you take two rocks and put them side by side, they're being attracted to each other by gravity, but you can't even perceive it.
No.
If you're going to take two magnets and put them side by side, you'd be lucky if you don't lose your fingers, because the forces are so great. And that's how vastly different those two basic forces are.
So let me ask, when it comes to magnets, why do magnets have more gravity than those rocks? Like why because we manufacture
they have
them
the
to be that
same
way?
they have the same gravity,
Mhm.
but the forces attracting them are the forces of electromagnetism, which is one of the other four primary
Mm.
forces of the universe. And
Mm.
why magnetism is such an incredibly strong force between matter and gravity is such a weak force between matter is not understood.
Mm.
Explain the speed of gravity, because they say, like you mentioned earlier, nothing's faster than the speed of light. But then you hear those things where they say, well, a black hole is tied into gravity and light can't escape that. So how do they even like determine what the speed of gravity is? I know you had mentioned a planet doubling and filling that on the other end of the
The
universe. And
the 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 effects of gravity and all the formulas are instant. There's no time involved. So as soon as you have the mass, you have that gravity, and that gravity affects the entire universe. So it's like if you set off a light bulb somewhere, it would take millions of years to travel to other solar systems and other
yeah.
galaxies, and you know, millions and billions of years. But if you were to be able to create mass, and you can convert energy to mass and mass back to energy, by the formula equals mc squared. It says that if you create mass by making energy, the effects of that gravity are present in all the universe the instant it's created. So the effects of that gravity reach the outer edges of our universe instantaneously, even though
So
it's billions of light years away.
a simple way to think about it, if the speed of gravity would be like infinity miles per hour, because the speed of
Yeah,
light's like what,
it's
186,000 miles a
instantaneous.
second?
It's infinite speed as far as it affecting other objects.
So how did they measure that? How did we measure how fast the force of gravity is? Which is I find real interesting.
I don't know the exact methodology they use, but it typically involves a few satellites in space measuring space gravity, and then there's events somewhere where a neutron star or something or a supernova goes off, and they can feel the waves of gravity going through the universe, and no matter where you are, the timing of it, I believe, is exactly instantaneous and things of that nature. So I believe that's how they've measured it physically.
So and that's interesting. So we're saying that the speed of gravity is almost unmeasurable. It's so fast that we can't even measure its speed. And we talk about UFOs and time travel and all these different things, getting out in the fringes. But if you were trying to navigate the universe, you would need something like that. If you needed to go a trillion light years, whatever, you would need this speed of gravity and whatever that is, which is kind of defying our logic.
The simplistic way of traveling from one side of the universe to the other is simply you have to step out of the three-dimensional space, where you are, and then reappear in three-dimensional space somewhere else. Now, you can have a piece of paper and you say, what's the shortest way to get from one side of the piece of paper to the other side of the piece of paper? If you're here and you want to be here, most people think, well, we have to just go in a straight line across it. But in reality, you can bend space, time, and everything else, and you can be on the same spot. You can just step over.
And do you think that's kind of how gravity's working?
A visual way of gravity is basically like a taut bed sheet, and you're putting bowling balls and tennis balls on it, and the heavier objects make deeper distortions in the gravitational plane, and the heavier objects will make a deeper hole, So if you put a marble close to it, it'll get sucked in faster because the ramp is steeper.
And
So that's a very visual way of seeing how gravity works.
So when you have space, let's say it looks like this,
Yeah.
then you put something very dense, even like a black hole.
Yeah.
It's going to pull the ends together. So
Right.
that's space right there. And let's say that's 1 trillion miles between
Yeah.
here and over here. So then you take something dense like a black hole, which is an object that's so small but incredibly dense and heavy.
Yeah.
It will press down the space-time and
Absolutely.
then hold those obviously very far apart places closer together almost instantly.
The black hole sucks in everything, including light. It has so much gravity that a photon, which has mass, can't even escape. At the speed of light, it's not going fast enough to leave. It's trying to leave and gets sucked by gravity and gets pulled back in. But black holes actually do evaporate, which is, another cool thing. And they give off what's called Hawking radiation, it was theorized by Stephen Hawking that black holes have to give off energy. Otherwise, the loop couldn't go on forever, or else the universe would eventually cease to exist. So black holes do give off energy and become lighter because they're giving off energy.
Which is interesting because I'm sorry, go ahead, Dave.
Oh, can you put up Vegan Higgler's comment from 12:13 p.m.?
Well, hold on.
Let's address this.
12:13. Here we go. Gravity holding all oceans on the imaginary globe is laughable. Oh, they're a flat earther. That's why.
Oh, vegan. But can you address this though, Heiner? He said gravity holding all the oceans on the imaginary globe is laughable. It can't even hold a bird from flying.
Well, a bird happens to be particularly light, and a bird is, basically swimming in a very low density ocean of air. So a bird is simply like a fish propelling itself through the air, which is a very, very, very low density fluid, and has enough wing surface area to push down on air and counteract gravity. So birds are certainly flying. No physics is needed to prove that. One can just peer out the window to confirm that fact.
Yeah, and I think people have their own ideas sometimes of science, which is, look, this is where theories come from and sometimes facts. So people want to believe the earth is flat. Go right ahead. There obviously is a lot of study been done, and we've done a lot of different things, and it seems to show there's a globe, but I mean, who knows, anything's possible.
All I know is that I've flown around the planet several times, and I've managed to go all the way around the planet in a straight path, like, on some of my longer trips. And when you're flying at high altitudes in a plane, you can already see that the earth is curved. You don't need to go all the way to space. And the ancient sailors, from long time ago, already knew that the world was round, because they knew that when you looked out over the ocean, a ship disappeared over a round horizon, and the person that was up in the crow's nest could see land first. And when you see a ship coming, from sea to port, you see the top of the mast first, and slowly the ship rises up out of the ocean until you can see the whole ship. And that is because it is sailing over the curvature of the earth towards you, and that's why the top of the ship appears first until the whole ship is before you when you're in harbor.
A great example.
Yeah, I've always wondered if the flat earthers thinks the moon or Mars or other planets are flat too, or if they actually think they're spherical.
Of course they would be.
Huh?
But they're all wrong, because of course everyone knows the world is hollow.
Another interesting theory, but
And there's dinosaurs just like on the bottom and living inside the Earth.
Oh,
oh
don't
yeah,
ruin
yeah, I've
my
seen the new
my
Godzilla
journey
movie.
to the
Sure.
center of the earth
That's right.
fantasy.
Absolutely.
Yeah. So that's interesting. I mean, so if one were to conceptualize saying, like, first you started off talking about we don't really understand why gravity is so weak, and you had told me an interesting theory about that gravity is what?
It's a force of attraction between all mass, and they think, like, one of the recent theories, it's far from being proven, is that we are swimming in masses of mass from other dimensions and universes that we can't see, but the gravity of the different universes are all interacting. So it'd be like us swimming in a sea of material, and we're being pulled in all directions simultaneously. That's why we're almost buoyant and floating, because it'd be like being in the pool swimming. All forces are in equilibrium. That's why you can just lay there and swim, depending on your BMI.
Right.
There's that's just one of the theories that cosmologists are constantly trying to figure out why gravity behaves like this, and we don't have the answer at this point. We may one day have the answer.
And I kind of like the idea that we try to explain how we could transverse universes, but that makes sense that if you had a way, whatever that was, I mean, obviously beyond our technology now, that you could, like you said, gravity can take long distances. If this is a trillion miles to the other side of my hand here, and you just simply figure out a way to bend this with some type of dense gravity and create that black hole. It pulls those two together, and theoretically, you can, however that would make sense, however they would make that make sense.
The current math does not preclude folding space and stepping out of space here and stepping in space there, and that can be 100 million light years apart. So nothing in the math that I am aware of at this point says that that's not possible. We don't know how to do it, and it would take the energy of 1,000 exploding suns simultaneously to achieve. But it doesn't say it's not possible. So if we had that type of if we had that kind of energy, we could possibly bend space and step out of the universe here and step in there.
Hey, what about this comment? This guy said gravity has never ever been proven. It's just a theory. Is it just a theory, or have they proved it in some way?
Many things are simply theories, but if you observe, if they follow all the rules indefinitely, the reason it's called a theory is because we don't understand all the physics behind it, and we cannot mathematically prove, but we can with absolute certainty calculate gravity. We can with absolute certainty calculate the effect of one object on another when we're sending a spacecraft out into space and circling the Earth. We know exactly what the gravity is. We know what the speeds are. We can calculate exactly its trajectory as it's going around the Earth, and even we slingshot off one planet and bounce off and go to another planet. Like Voyager 1 and 2, I believe, did 2 or 3 slingshot maneuvers in order to get into the interstellar space, outside of our solar system. Voyager 1, unfortunately, just recently stopped communicating. But, I think it's been about 46 years or something for a space probe that was expected to last a couple of years. So it's done well for itself.
Yeah, pretty good. Long-term relationship, then it just ghosted us, I guess. 46 years.
It may be ghosting us at this point. They're trying to get it to wake up and talk to us again, but it appears to be in a reboot loop of some sort.
Here's a question. In the world of ufology, they talk about anti-gravity craft. Do you know anything about the potential science behind like how these, I don't know if you believe in UFOs or aliens, but these spaceships operate?
There is, again, no math or laws that I know of that preclude generating like an anti-gravity force. Of course, we don't know how to do it at this point. We don't know how much energy it would require. But they also theorize there's places in the universe where gravity acts oppositely, and basically things repel each other. Like two magnets going the wrong way will repel each other. They believe that there's portions of the universe where that is possible, that is occurring. And that's another theory they have as to why the expansion of the universe in some areas, or in many areas, is expanding and accelerating. So, which is another thing they still don't understand why it's accelerating.
Well, this is interesting because we're always trying to figure out how these objects that we see the Pentagon coming out releasing stuff about these objects that defy what we understand about physics. And when you start getting on subatomic levels, people who want to say that nothing really exists the way we think in science, well, to some degree, if you go on a subatomic level, they have spooky particles that do things that just defy every bit of logic. Like they have objects that, would be an example. And I believe it's a mun. It was a mun, I believe, that it appears here, but then has no path or how it got over here. Kind of like you're sitting on Earth and then you appear on Mars. And nobody can explain except for maybe it drifted into another dimension but these things are incredible. And, you start talking about how a UFO would work or time travel. It would be in these really weird outer peripheries of what we know about, science.
A lot of the subatomic particles do not conform to the three-dimensional laws of the universe that we experience daily. Down at their subatomic level, they act very differently. Like if you took a quark, or like if you had a little quark in your hand, which is impossible, but and you took a Sharpie and made a little mark on the quark and you rotate it. Hello, Arthur. If you rotate it 360 degrees, the Sharpie mark would no longer be there. You rotate it another 360 degrees, the Sharpie mark would now be there again, because they are so dense for their size. They don't exist in our three-dimensional universe correctly. Space is warped around them, and you have to rotate them 720 degrees in our three-dimensional universe for it to have rotated once. And these are all experiments that they're doing at CERN with these accelerators, and they're smashing particles into each other at the highest speeds we can generate. But a lot of really strange physics starts happening at the micro, the nano range of things. It's really remarkable.
So I just want to introduce Arthur Ray. He has a very large YouTube channel. He does updates. He's in Estonia. He does updates on Ukraine. Go see his channel, please. Arthur. So it is ATREREHI. Arthur Ray.
Hi,
So pleasure to have you here,
I
buddy. Any UFOs that you've seen, ghosts or something strange? Does Arthur have any paranormal things in his closet?
I just popped in and Heiner was speaking about something I already don't understand much, but I guess this is my chance to learn. So I'm a big ear. I'm here to learn. So go ahead.
We get an interesting question here, Heiner. I do have an opinion about this. The Philadelphia experiment. I'm sure you're familiar with it. What do you think?
I haven't really read enough about it. I know the concept was they were trying to make a ship invisible with cloaking, and it reappeared somewhere else and things of that nature. I haven't really researched that to see, what exactly they're doing. I don't even know if they've released what they did and how they did it. I don't know if, but I'd happily read more upon that experiment and how it was conducted if it's been declassified.
Well, I can tell you this. Now, whether this is true or not, this is a personal story of mine. I was a banker back in the early 2000s. I had an older gentleman worked for, I believe it was General Dynamics or one of the big companies way back, and he was fairly old guy. He was in his mid 80s, and he told me he worked on that project, and he said it's just like somebody has a story and you tell somebody else, and it gets really blown out of proportion. He said what happened was, he pointed at my screen. He said, "See your screen of your computer. What we were trying to do is we layered a ship with this stuff, and there were frequencies or what, and I think it was the beginnings of maybe radar, and they were trying to, as my opinion, he didn't say this, but I thought about later, trying to block radar from seeing it, and maybe they were giving off microwaves or something. I don't know what it was, but he said what happened is the crew, when they turned this thing on, all got extremely ill. They all got very ill, and afterwards all had very bad health problems afterwards. So this is what
a frog in the microwave will also get very ill and have serious health consequences. So depending on what they were doing and what energies and what frequencies, I own a small communications company, and the radios we use are very low power, but the higher power radios that like a cellular carrier will put up on a 400 or 500 foot tower, they'll emit hundreds of watts. And if you were to hold a chicken in front of there long enough, you would eventually cook your chicken.
That's the term.
Quick comment on that then, Brian. So it sounds like all they were trying to do was make ships not appear on radar as so invisible to radar, but not like invisible in the real world, as far as like if you were standing and you could see it, you would still see it, right?
That would be my assumption. He didn't say what exactly frequency or what they were exactly. My assumption was afterwards, and I thought about it. When everybody talks about the ship disappeared. Well, maybe it disappeared on radar. Maybe it actually did, but the consequences was everybody got really ill. So it worked, but didn't work in that it almost killed everybody, or maybe killed people that were on the ship itself. That is what he had told me. Now, how factual it was, whether he was just pulling my leg, I can't say. But yeah.
Before we knew the full effects of ionizing radiation, we used to stand there and watch nuclear explosions in a field, and we used to give soldiers a little piece of glass to look through and watch the explosion, and that didn't have great health effects to the viewers either.
Yeah, if you go on YouTube, you can actually they have people who talk about soldiers who were put near a blast when they had the blast radius. They covered their face, and this is what they said, and you can find the videos, and they saw the bones in their hands when the blast came over them and hit them. There was so much radiation.
The light would be so intense that, like, if you were standing behind somebody that was not dressed, you would likely see their entire skeletal form. You might be able to see their internal organs. The light is many, many, many times brighter than the sun at the time of explosion, like
of a nuclear
explosion.
Yeah.
So the light is incredibly intense, and it, with your eyes closed and your hands over your eyes, it's probable that you didn't damage your retinas with the intense light, just because you filtered it with your hands and your eyelids. But it's an incredibly bright light, so I don't recommend looking at any thermonuclear explosions.
Well, burn your retinas.
It's not well advised. I see we have a question here. Yeah, I see we have a question here about gravity.
Don't be
And,
looking at nuclear explosions.
Yeah.
Yeah, let's go over this question here. An honest question: aren't there places in the world where gravity is much weaker than in other places? What is your view on that?
There is gravitational anomalies all over the Earth, and they're very modest, and it's due to the density of the ground beneath you. So somewhere where there was lots of iron ore, deep under the earth, gravity there would be maybe 1% greater than somewhere else. The only real substantial difference in gravity on Earth is between the equator and the poles. And at the North Pole, you're spinning on your chair on the center, and it's not trying to throw you out of your chair. When you're on the side of the Earth at the equator and the Earth is spinning at 1,000 miles an hour, essentially, is the speed that you're traveling when you're standing there hanging off the side of the Earth at the equator. The Earth is trying to eject you off like if you spun something that was wet and the water flies off of it. But again, the acceleration from spinning once in every 24 hours is not nearly what gravity is. If you want it to be equal to gravity, you'd have to circle the Earth approximately every 90 minutes like a satellite. Then you'd be in equilibrium with gravity. If you go faster than that, then you're going off into outer space. So terminal velocity, or around the Earth, is around 17,000 some odd miles an hour. Then you'd be weightless, circling the Earth as an object.
So here we go, and maybe your thoughts on this. So we all got to come to this when we talk about gravity. Mantis Gardens 13. I think the fact that Nikola Tesla wanted nothing to do with the Philadelphia experiment after he looked into it says a lot about how effed up it was.
Tesla was probably the most brilliant scientist of his day. He, his experiments and designs, and even the fact that we're running AC power is all thanks to Tesla. So there's no question he was a gifted genius designer of electrical and magnetic systems. But I don't know, what his thoughts were on the Philadelphia experiment, or apparently he wasn't involved, but I haven't really studied the Philadelphia experiment in great detail. So
let me ask you a question about Tesla. Do you think he had all these incredible breakthroughs that were hidden by the government or concealed? Do you think he had some special insight that has been taken away from the public sphere, public's eye?
I don't believe so. All of his great inventions, just AC power and transformers and three-phase motors, we're using all of that today to great effect. The things that he wanted to do, which was like broadcast free electricity to everyone without wires, to this day we cannot do that. And like, if we could transmit energy even a few kilometers up to a drone from the ground, so a drone didn't need batteries, fuel, if we could just transmit that energy to them, with the planes, if planes could fly and we didn't have to put fuel in them, and we could transmit up energy, via microwaves or whatever to a plane, we'd likely be doing it, because it would be greatly more economical if that was feasible. But sending energy at great distances like that, it's a little difficult to do. Like we do beam energy from a little plastic plate to a cell phone inductive charger, and we're sending a grand total of 1, 2, or 5 watts, a distance of half an inch. And even those are challenged, if you don't have your phone exactly in the right spot.
Well,
I got a question about that, actually. Like, if you have a wireless charger to your phone, how big is the energy loss compared to when you have a wire connected to the phone?
It's significant.
Significant, yeah.
It's
So
significant.
bigger batteries, you couldn't charge them like that.
You can, but you lose energy in everything you do, because you're basically converting electricity, into magnetism, and then inducing it in another wire, and it's not highly efficient.
So,
it would,
Heiner, you don't think we actually, or Tesla, developed the technology? You don't think that ever happened? You're not on board with the theory that they're holding and suppressing it because of all the money that people want to make through oil and all this other stuff? You think we don't even have the technology or never had to begin with?
no. Secrets like that, they're impossible to keep, because someone in the world would parallel invent it, with the greater understanding of physics that we have today than we had at that time. These things would get out naturally. There's very little that you can, on a conspiratorial basis, keep, secret from the entire planet forever. Like if two people know the information, chances are it's going to get out.
Well, of course,
sorry.
Our guy Vegan Higgler said Tesla was murdered. Everybody knows that. So maybe they killed the secret with them.
Go ahead, Otto. What were you saying?
I just saw a video in early 2000s. Some guy invented a car driving on hydrogen in his backyard, and it actually worked. Drove on water, and the guy was poisoned the next day. So I don't.
Oh,
I don't
that
know
happened in the 80s. Also, they killed some dude in Vegas, man.
Yeah.
Well,
I don't know what's behind it, but you might think oil companies maybe.
The oil companies could very easily just simply corner the hydrogen market and start making hydrogen and distributing it. Hydrogen is it's a wonderful gas. When you burn it, it makes pure water. Sounds super, but hydrogen as a gas is a real nuisance. It is such a small molecule, it will travel right through the wall of a steel container. And not only will the hydrogen travel through the wall of like a steel tank, as it's doing this, it will react chemically with the steel and make it very brittle. And it's called hydrogen embrittlement. So you will one day fill up your hydrogen tank to its capacity of 3, 4, 5,000 psi, whatever pressure you're operating at, and instead of leaving the gas station as a happy, hydrogen driving person, you may find that your steel tank fragments like a fragmentation grenade and explodes and kills everything around, and then the ensuing sparks also makes a hydrogen explosion thereafter. So it's not a trivial gas to work with. Methane is a much larger molecule, which is natural gas. Even it is challenging at times. But yeah, no, hydrogen is a cool gas, but it's difficult to deal with, and it has to be held at very high pressures. Cannot be liquefied, practically.
Can I ask about another subject?
Sure.
Nuclear fusion. Is it fusion right that we recently made a process that actually gave us a sum of energy which is greater than put into it?
Yep,
how far are we with it? And
we're currently, close to building, with approvals and a lot more investment, a working small system. Using lasers to put incredible energy on a spot, and magnetic fields, and it's a very complex. It's not like fission, which is a normal nuclear reactor. By comparison, is super simple. You throw a bunch of uranium in a pile and you fire it up with some protons, and off it goes, and a nuclear reaction makes heat. You cool it, and that cooling makes steam, and you make electricity. Everything's radioactive and a bit difficult to deal with. But compared to fusion, it's it's almost like a kindergarten level project compared to fusion, with the levels of the pressure and temperature and everything you need in order to achieve a sustained fusion reaction. But if we get there, that'll certainly be the gold standard, where we can produce limitless energy without any nuclear byproducts that are radioactive. We'll just be taking hydrogen and making helium out of it all day long, which is something we need anyway. We're running out of helium on planet Earth.
Hey, Viking, real quick, you can I just made you a managing moderator, so if you want to pop up any
I can pop up comments. Oh, okay. Richard G, what's up, man? Shout out. He always pops in, so say hi back there. Here's a question for you, Heiner. What do you think of, and this is because Vegan Higgler had posted some comments and put this in my head. What do you think about the moon landing? Did we have the technology and science to actually do it in the 60s, or was that fake?
No, we absolutely landed there.
Oh, we did, 100%.
With a cheap hobby telescope, you can actually look at the moon and see, tracks. You can see scrap. We littered on the moon like we litter everywhere else. So yeah, there's actually a reflector that we installed there for pulsing lasers at the moon and getting a reflection back, so we can measure the distance to the moon very, very accurately, because we wanted to see it, its orbit as accurately as possible. So I don't think.
I got to ask you a question.
Reflector got there any other way.
Heiner, is this a true physics fact right here? The only reason the Earth spins is because Viking Samurai throws so many helicopter kits. Is this possible?
Oh, absolutely. And it'd be even more effective if he threw them at the North Pole or the South Pole, but he'd have to make sure he does them in the correct direction.
I threw plenty of them in Germany.
They're going to be less effective there than they will be at.
Okay, we'll have to shoot the sequel up higher than.
Correct. You want to be on axis if you want to spin it faster.
Okay.
And if you want the day to be longer, then you got to go in the opposite direction, slow down the planet.
Because if anybody wants to true wake up in the morning, go follow Viking on Instagram, because every morning I open my Instagram, first thing I get is a kick in my face, like kicking the camera. Okay, I'm up.
I'll wake you up, man. That's funny. Here's a question, Heiner, and people actually made jokes about this, but it's a good question. When they have that footage of Neil Armstrong coming out of the spacecraft, right, and setting foot on the moon, and he makes his whole, one small step for man thing. And he's like the first dude who ever stepped foot on the moon. Like, who set up the camera then?
I believe that camera was a fixed camera on the outside of the spacecraft.
Okay.
It was like the 60s version of a GoPro on the side of the lunar lander.
Cool, man.
So this is an interesting one. Well, first you have to assume time exists, LOL. And now they're not even sure of that. Aging is a disease now. Well, aging, and Heiner and I talked, this just has to do with telomeres. And that's why you have people with a thing called progeria. So you're 10 years old, yet you have the body of an 80-year-old or 70-year-old. That you age just because of the length of your telomeres. And the older you get through cell divisions, we know they get shorter and shorter. And when you hit the end, that's it. You can't live further than that.
The cells can no longer effectively divide. And if the cells can't divide, they can't do regenerative construction of your body to do maintenance and repairs. So essentially, you fall into disrepair. Now, time certainly exists. And as Einstein has taught us, time is relative. And your time with respect to the universe slows to almost zero when your speed approaches the speed of light, and it is fastest when you're stationary. So so time is a really cool concept.
Can I say this, Heiner? And I want to ask you about this. If we look at it, is everything simply being dictated by the theory of conservation, where atoms cannot be created or destroyed. So everything exists always at the same. So, when you look at time, our time is relative to beginning and ends, because we live, we die, the day starts, the day ends. Everything in our world, philosophically, in our head, or the way we perceive reality, is just based upon our experience. But when you look at the laws of conservation, the theory of conservation, right? Atoms can't be destroyed, they can't be created. So in that place, time is not really an effect, because these things never expire, they never get created. So on that level, time becomes less conceptual, except for us to try to understand an experiment or put something within its context, right? Does that make sense?
It's there's many ways to think about time, but time is a very interesting dimension, so to speak. And we know that time for us can only go in one direction. We can't travel back in time. Again, the math doesn't say it's not possible. Again, we do not know how to achieve this. But as far as matter, matter can be destroyed and converted into energy, and energy can be converted back into matter. So all through the universe, there's, at every second of every moment of history, there are particles just appearing out of thin air. Just boop, there it is. And a little later, boop, there it's gone. And there are short duration particles that they think are stepping in and out of our three-dimensional universe, or they're being created, and then they decay and turn back to energy, and then they're being created again. And again, many of these processes are not understood either at this point.
But is it the thermodynamics second law that no energy can leave an isolated system? In that case, there was a big bang, and all of the energies that exists right now, some of it in the matter form, some of it just as energy, just came into being with the big bang, and nothing else has ever been. Nothing else was added to it later. It's just everything exists now, right?
Everything that is in our three-dimensional universe that we experience was there at the beginning. And has been there the whole time. It's changing, shifting, as suns turn through fusion matter into different compounds. But as far as we know, the mass of the universe is a finite number, which is enormous, but it's finite and does not change, as far as we know.
Here's a question going back to those telomeres and aging. Do you think that science will ever arrive where they could, if not stop, well, not only stop it, but potentially reverse it, where somebody, barring like a car accident or something, could essentially become immortal?
I wouldn't say immortal, but a gifted, genetic scientist probably today, using CRISPR, should be able to modify the human genome in such a fashion that our telomeres no longer shorten. There are bats, for instance, that are, like 1 inch large, that have healthy lifespans for 20, 25 years. And it completely violates the rules of how long animals of a certain size live. Like, generally, the smaller the animal, the shorter it lives. I know in dogs it's inverse with them. Mm-hmm. But generally, like, a mouse lives 1 or 2 years at most, or an elephant lives 100 years, and a blue whale even longer. So there's a certain bat that lives very healthy with no visible signs of aging for its entire lifespan until it eventually dies. And these bats do not shorten their telomeres when they do cell division. And I can assure you, Big Pharma is researching these bats to see if a pill could be developed that would allow your telomeres to remain the same length every time you do cell division. And that would mean you would lead a healthy and unaging lifestyle for a much longer period of time. So you might live in youthful health for 50, 100, 200 years.
Well, here's the
Would be
problem.
great.
They'll probably discover it when I'm 90.
Yeah. So then you're stuck at 90. You're probably better off just letting it go
You
at
may
that point.
you may not want to take that pill at that point anymore.
Yeah, not so much, man.
Unless you want 90 for 90 years. I mean,
crapping in a diaper for the rest of my
Here's a question though, Heiner. Like, why do those bats eventually die if they're not really aging?
Again, we don't know the mechanism, but they don't age as far as we can tell. They don't go, like a human where, at age 20 we're at peak fitness, and 30 we're doing still great, and then 40 it starts going down the hill, and then we do that long downhill slide. The bats don't seem to do that. And they're in the lab right now trying to figure that out, because I'm sure if they figure that out, that would be very lucrative to somebody.
Oh,
microorganisms also do that. There are some microorganisms that show immortality, but most of them die from means of being eaten or diseased or something. But
okay, I have to interrupt. I actually have to go now, but it was really interesting, Brian and Viking and Heiner. I mean, I've learned so much from this 20 minutes, more than I learned my entire school time. So yeah,
the value of
come back anytime.
Education.
Yeah, I'll see you next time, guys.
all right,
All right,
see
thanks,
you, buddy.
Hey, let's cover this, man. How likely is it that we are living in a simulation?
I'd say it's fairly unlikely. Like the fact that I have to reboot my cell phone, every few days because it's crashed, and my PC crash. If this is a simulation, I would have expected it to crash several times. If the operating system is as effective as any of the ones we're currently running on this planet. So,
how would you define it crashing? Because look at this. So, for example, we don't know what humans have done, say, I don't know, 10,000 years ago. Maybe we had very advanced technology and then the simulation crashed and we kind of had to start back from the Stone Age.
Philosophically thinking, you could support. There's as much evidence for that as there is for anything else. Because if you're inside a bubble, much like what was that movie where?
With Jim Carrey?
No, he was living in a little imaginary world, and he had to sail his little boat to get free.
Yeah, what was that? It was a Truman Show.
Truman Show.
Yeah.
So, if you were living in the Truman Show, it would be very, very difficult to know that you're in the Truman Show, because you were raised in that bubble, and unless you have a way to see outside the bubble, your entire reality is the bubble. Similarly, people that live in very closed dictatorial societies do not know how the rest of the world lives.
Right.
They're in their media bubble. They're in their closed in prison camp like North Korea. And
well, like a tribe, right, on an island 500 years ago, 600 years, they had no clue of the Easter Island. The people on Easter Island would be a perfect example.
Yeah, they would not have likely known that the Egyptians were building pyramids. They would have been unaware of that fact.
Yeah, unless the Atlanteans were going around giving updates right in there.
Well, I happen to believe that man traveled around the earth a lot more than we give credit for. And I happen to think that South America was populated by different people getting to South America differently than the natives of North America.
Well, the Clovis people are very confusing because they weren't supposed to be here.
Yeah.
Their genetics. And one of my degrees is in genetics. I mean, it's only a minor, but something that's always fascinated me is we find these genetic anomalies in different.
We find European DNA in first Nations people in North America predating contact, with Christopher Columbus. However, I explain that with the fact that the Vikings were on Newfoundland 1,000 years ago, and the village or camp that they had in Newfoundland was not a village. It was basically a transfer station where they would stop, restock for fuel, like food and water and whatever, and then they were rowing on somewhere else or sailing on further. And the only logical spot for that was, mainland North America. So I don't think they were freezing to death in northern Newfoundland, in their little rock huts. I believe they were probably, sailing to Martha's Vineyard where things were much more comfortable.
Now, I had read a long time ago, I believe it was in Weird America's a book. I think it was called Weird America, that a Roman scepter was found with in a trash, what would be considered like an Indian trash pit, where they had thrown bones and stuff like that. And there was a Roman scepter, not a scepter, their legionary scepter, I guess they called. I forget exactly. We're going many years ago. And there was this idea, like, how did that get in there? We're going way back. Did the Romans actually come here at one point?
It's more likely a Viking took that off a Roman's dead body or something, or found it as treasure and loot and brought it with him and offered it to a chief as an
offering
gift, as an offering for peace. There was substantial trade routes in North America 1,000 and 5,000 years ago, where we find flint from northern Canada, in southern U.S. and the native tribes all across North America had contact with each other, and they did transport goods that were of value to them all over the continent.
It's interesting, but the one thing, working in medicine myself, is disease. Maybe we would, had they been here in number, the Vikings and stuff, we didn't see some of the old world diseases here. We didn't see, the smallpox and all these things that were plaguing Europe at that time. So it's interesting. There's so many things that can be, but then again, we find things that are anomalous.
Yeah, one explanation for that could be that the Vikings, when they came over here, were basically isolated on Iceland and Greenland and Newfoundland for extended periods of time. So by the time they arrived to North America, years later, after being pushed off the European continent, everyone that was going to catch one of these diseases may have already died and or recovered from it and now been immune, and they didn't actually carry that with them.
It's interesting. So many things that just are you can add questions, but then those questions lead to more questions, and you're like, it's a fascinating rabbit hole.
If you take a small group of people and isolate them from all other humans, they will eventually become sanitized, where they will clear themselves of all the viruses and stuff, because they'll become, once everyone's got, COVID once, and everyone's got the cold and the flu and this and that, and no new variants, can develop in a community of 20 people, then theoretically they can sanitize themselves and move on and not be infectious after a period of time. Same way we do quarantine for astronauts we're sending to the space station. Like we're isolating them for a period of time so that we can confirm they have nothing. And you can isolate one person, or you can isolate 10 people together. It's, as effective, except if one gets sick, then, your isolation is
real quick. Here's something for you. Was we were talking about simulations. If we want to talk about something that defies logic, if we look at the slit experiment paradox, the slit, when you send I believe it's the electrons through, and when you view it, it functions as straight lines, but when you don't view it, it turns into a wave. Do you know what I'm talking about?
Vaguely, not exactly. The the slit experiment, you know, I'm familiar with, is that where you're trying to have a very narrow aperture, show that light is
A beam or a wave.
and,
Yep. Yep.
it's light acts simultaneously as a particle and as a wave, right? So it's kind of a very unique particle in how it behaves. And you can also have entanglement between photons, where you have two photons that you've entangled together, and you turn one of them and the other one turns in sympathy with it, no matter where in the world it is.
That's right. That's interesting.
That's another spooky force that they're, you know, I think they have a better understanding how that works, but still, I find that remarkable that a photon on one side of the Earth and a photon on the other side of the Earth can be entangled, and when you act upon one, the other one reacts instantaneously.
And I think what you're talking about is when they were connected at one point, right?
Correct.
And then when you separate them, no matter how far you separate them, whatever is done to this one will happen to that one. Yeah. Which is strange. So if you put it all the way on the one on the North Pole, one on the South Pole, they still will interact exactly the same. What you do to one affects the other. So
and distance is immaterial.
Yep, irrelevant.
They're called entangled particles at that point, right?
Yes. Yep. So Viking, you want to close it out, brother?
Yeah, guys, thanks so much for joining this. We're gonna just do interesting, different topics every week, every Saturday. Tune in. Next week we have David Richardson. He is a ninja, he is a magician, and more. And yeah, he's down to answer any questions you guys might have. He spent time with Frank Dukes, by the way, so he might give us some very cool insight related to that. Dukes Rue training. I think he trained with the Bujinkin. So amazing magician, by the way. Very cool guy. And that'll be our guest next Saturday. Heiner, thanks so much for joining. This was a fascinating discussion. Like our buddy Artur said, he learned more in 20 minutes than he did in his entire formal education in Estonia.
I hope not.
Doesn't say much.
I hope that is not true.
Yeah, there's probably some truth to it. Hey, Heiner, can you hang on a second? I want to ask you a couple things after Brian. You want to cut this broadcast?
Yep. All right, everybody. Thank you for joining us, and we'll see you on next Saturday. Same bat place, same bat time.
Definitely.